So welcome to this short video presentation on the course structure of the engineering degrees at Durham University. My name is Will Coombs and I'm the admissions tutor for engineering programs. I'm also an associate professor in the department. And you can see that I'm currently sitting in one of our teaching laboratories, and I'll explain a little bit more about how those laboratories fit into our program as we go through the presentation. Now, we're a little bit unusual in the UK in terms of engineering degrees at Durham, and that we offer a general engineering program. And that means that all of our students that are admitted onto our degree, for those first 2 years, they will sit the same lectures, they'll learn about all the different disciplines of engineering, they'll do the same practical experimentation, and it's only at the end of their second year where they actually make a choice about what engineering discipline they would like to specialise into. And we believe that that's the right way to go. One, because engineering as a discipline is becoming more and more multidisciplinary and transdisciplinary, so having core knowledge across all the different engineering areas is really important, but also we think that students should be informed about their choices before they make them. And so they can actually learn for 2 years about all the different engineering disciplines before making a choice. And we really do believe that that's the right way to go, and it's not just our courses that are like that. We have this general engineering philosophy within the department in terms of our research as well. And so at the end of the second year, in the third year, students would then choose from 4 different options. So we have civil engineering, mechanical engineering, electrical engineering, and electronic engineering. And if these students were on our 3-year degree or our Bachelor's of Engineering or our BEng degree, then that would also be their graduating stream. For those students that are staying on for the MEng degree, the Master in Engineering, they would have an additional 4th year where they have further choices. And at Durham, the vast majority of our students actually do the MEng degree. Around 80% of our students take that MEng degree. And this is very much linked into chartership requirements. So if you want to become a chartered engineer, you need a master's level engineering qualification or equivalent. So that's why most of our students choose to do that MEng degree. And if you are in that 4th year, you'll have further choices depending on your 3rd year specialism. So civil engineers would stay on the civil route, electronic would stay on the electronic route, but mechanical and electrical have different options. So aeronautical engineering, mechanical engineering, renewable energy, and electrical engineering are options depending on the 3rd year stream. So you can see that mechanical engineers have the most options in the final year, and the electrical engineers have 2 different options in that final year. It's also really important to say that students can also transfer between the MEng and the BEng degree freely during those first 2 years. So it doesn't matter if you came to us on a BEng program and you decided actually you wanted to do the 4-year degree, that's absolutely fine. You can transfer until the end of 2nd year. What I'd like to do in the rest of the presentation is tell you a little bit about the different ways that we would deliver the knowledge that you're going to gain during your degree. So let's start with lectures. Lectures are really important for us in engineering. It's a key way that we teach you fundamental engineering knowledge across all the different disciplines. And as a 1st or 2nd year engineer, you'd expect to have about 12 hours of lectures per week. So an academic would come into the room, they'll be delivering new content, new engineering core knowledge, they'd be running through examples, asking you questions, etc. Getting a bit of class participation going, getting people to think about the different options and the answers to the problems being posed. Those lectures are really reinforced by physical laboratories, and you would do those in a space a bit like this. Okay, so you'd be here for 3 hours per week, you'd be working in pairs or in threes, doing physical experimentation to reinforce what you're learning in lectures. And there would be demonstrators around to help you, but really demonstrators isn't the best word. Perhaps supervisor is a better word, because you'll be the one doing the experiments. You'll be the one taking the readings, drawing up the results, coming to your own conclusions, analysing the data, etc. And the demonstrators will be there to challenge your ideas, but also to make sure things are safe. You'll have computer-based classes. So in the 1st year, we'll teach you how to use CAD, so computer-aided design. We'll teach you how to program and use various different analysis software. And much of that is done in our in-house engineering computing classrooms. You'll also take part in design and industrial projects, and most of the design activities you'll be working not only with an academic member of staff, but also a practicing engineer, so a professional engineer working in industry who's coming back to the university to work with some of our students. And really the culmination of our degrees is our research projects or dissertation projects. And in these projects, you'll be working on a real unsolved problem, normally one-to-one with an academic member of staff and also their research teams, their PhD students and other researchers. And these projects are very, very diverse. They can be based on theory or experiments or on simulation. Most of them use some sort of combination of those different aspects, and they really are the highlight of the degree for most of our students. And they're of such high quality that a lot of them end up getting published in academic papers or presented at international conferences. They're also worth half the final year mark for our MN students, so it sort of focuses the mind a bit and students really get engaged and enthused with their projects where they know they're solving a real world problem. In addition to the academic side of things, there are lots of other things you can get involved with at university, one of which is linked to engineering, is Durham University's electric motorsport team. I won't say too much on this because there is a separate video all about DUEM and what they do and their solar car, but really they're an extracurricular activity, a student-run society who build and race solar-powered vehicles. And on that team, there's a mixture of undergraduates and postgraduate students, and their achievement is absolutely outstanding. And you can see some of the evidence of that on the other videos that are focused on the solar car. You can also study abroad. So here is a world map of a few of the non-European partners that we have, where you can go for an additional year to study abroad. You can widen your horizons, you can learn something new, you can gain new experiences by supplementing your studies with an additional year abroad. And if you want to know more about this, then have a look at the web link at the bottom of these slides, and that'll have a full list of all the different partner institutions that we currently work with. You can also do a placement year, a work placement, and this is highly relevant to engineers. One example in the top middle is Oliver, who worked for Mercedes for a year. He then came back, finished his degree, and ended up going to work for Aston Martin. However, probably a lot of the reason he got that good job at Aston Martin was based on the work experience he had at Mercedes. However, what we also find is that many of our engineering students just do summer placements rather than a year in industry. And this certainly isn't hampering our employability statistics. We're currently second in the UK for employability, with 91% of our engineering graduates in paid graduate level employment within 6 months of leaving us. But it is another way that you can augment your studies by spending an additional year working in industry. And when our students leave us, they go to loads of different companies in the UK and around the world. And here is just a word map showing you some of the different companies that our students go to work for. Now, the size of the word dictates the number of students that have gone to work for that company. So you can see Rolls-Royce is very prominent. You've got AECOM, Atkins, Jaguar Land Rover, BAE Systems, most of the sort of big engineering companies you'd expect to see. But you also see some other companies which are perhaps not traditional engineering companies. And this demonstrates that an engineering degree is great training no matter what industry you end up going to work in. So that's it. I'd just like to leave you with a quote from one of our recent graduates, so George Crow, who graduated in 2019. And really he's highlighting what he liked about Durham. We're in a small, beautiful city. There's loads of things you can get involved with. And also he's developed loads and loads of skills in engineering that are going to be incredibly useful in his later life. And I think that kind of reinforces what I was saying on the previous slide about engineering being great training for future employment. So thanks for listening. Feel free to check out some of our other videos. We've got some on the solar car, as I mentioned. We've got some on the history of the department here at Durham, and we've also got some which are a bit more focused on the first couple of years in engineering.